Okay, let's dive into something that became incredibly familiar and for many quite controversial during the COVID-19 pandemic. PCR testing.
Right. And this deep dive, it's based on a comprehensive report that really dug into the scientific debates and, the public conception around all those PCR testing controversies.
Exactly. So our mission here is to sort of explore the landscape of these debates, but entirely through the lens of what this source material presents.
Yeah, we want to unpack this complex topic, understand the different viewpoints discussed in the report, look at the technical challenges involved.
And really get to the heart of why PCR testing was so central and sometimes, yeah, so debated. Think of this as a guided tour through the perspectives and the technical stuff presented in the report.
Okay, so starting with the basics. PCR. It stands for polymerase chain reaction. The report explains it's this, well, revolutionary technology developed by Kari Mullis.
Right.
Imagine you have a tiny, tiny fragment of genetic code, like a single puzzle piece. And PCR lets you make millions, even billions, of exact copies of just that piece.
So for COVID-19, it was used to find and copy the specific genetic code, the RNA of the SARS-CoV-2 virus. Its fingerprint, basically.
Exactly.
And we know this stuff can sound a bit technical, maybe intimidating,
Yeah.
but the report does a pretty good job laying out the debates, and we'll definitely break down concepts as they come up based on how the source explains them. It looks at different views on the science, its application.
And we'll walk through all of them neutrally, just as they're presented in the source.
So how did PCR, invented way back in '83, become the main tool for identifying COVID-19?
Well, the report notes its incredible power, its ability to detect even tiny trace amounts of the virus's genetic material. That made it the go-to for confirming infection.
Which was crucial for figuring out who was sick, tracing contacts, deciding who needed to isolate, all that stuff globally.
But the scale was just
Yeah.
immense.
Yeah.
The report points out billions of these tests were run worldwide.
Wow.
Billions.
Wow.
And this unprecedented scale, testing so many people so often, it really put a spotlight on some inherent limitations.
Limitations in how the tests were designed, maybe, or how results were interpreted.
Both, yeah. And also how all this complex information was communicated to the public. According to the report, these issues are really what fueled a lot of the intense debates we saw.
The report actually highlights that right at the start, February 2020, the CDC's first PCR tests had some, well, technical problems.
The source mentions an internal investigation found flaws that could lead to, well, results saying the virus was there when it wasn't. False positives.
Okay, what were the specific problems mentioned in the report?
It points to two main things. One was contamination in a key part of the test, something called the N1 probe.
Okay.
And the other, the report states, was a design flaw in a different part, the N3 probe.
What did that do?
It could basically cause a signal, the light the machine looks for, to show up even if the specific viral RNA wasn't actually present, especially in older kits.
And what was the impact of that, according to the source?
Well, the contaminant issue alone, it says, contributed to about 2% false positives in that first batch of tests.
2% doesn't sound huge, but with millions of tests.
Exactly. Now, the report does clarify these specific issues were fixed by mid-2020, and it actually pushed for better quality control going forward.
Right.
But it notes that these early stumbles probably did contribute to some of the broader skepticism about PCR reliability that, took root for some people later on.
Okay, so let's dig into the key controversies themselves as the report lays them out. First up.
False positives.
Right. Getting that positive result when you're not actually infected.
Why was this such a big deal, such a point of contention?
The report points to a few reasons false positives can pop up. Things like contamination when handling the samples in the lab. It's a complex process.
Okay.
Potential cross-reactivity, maybe the test accidentally reacting to similar genetic bits from something else, like another virus, though tests are designed against
But
this.
it's simple handling errors.
Yeah, like mixing up samples, mislabeling, human error can happen.
Does the report give any numbers on this? It mentions Public Health England reporting a specificity of 95 to 99%.
Okay, specificity. Break that down based on the source.
So specificity in this context is the test's ability to correctly identify people who are not infected, the true negatives.
So 95 to 99% means what? A 1 to 5% chance of a false positive.
Essentially, yes. 1 to 5% of people who are truly negative might still get a positive result under those reported figures.
And the report explains why even that seemingly low rate can be a really big problem, especially when not many people in the community actually have the virus, right? Low prevalence.
Exactly. The report uses an example. Imagine a place where only 0.1% of people have the virus, just 1 in 1,000.
Okay.
If you use a test that's 99% specific, which sounds really good for every single person who actually is infected and tests positive, you could get around 10 false positives. The report notes this can really distort the case counts and put huge stress on systems like contact tracing.
And the report also talks about the human cost, doesn't it?
It does. For individuals, a wrong positive result means unnecessary isolation, maybe financial problems, emotional distress, social stigma.
And in hospitals.
It could delay treatment for other conditions or trigger expensive, unnecessary follow-up tests and investigations. The report mentions that critics argued public health bodies didn't communicate these limitations well enough.
Leading people to think the tests were basically perfect.
Right. That they were infallible, which no test really is.
But the report also presents the other side, the counter-argument.
Yes. Proponents of wide-scale testing emphasize that when lots of people are actually infected, when prevalence is high, those false positives become much less significant compared to the true positives.
Because there are just way more true positives, though.
Exactly. And in those situations, the test's sensitivity, its ability to actually detect the virus when it's there, becomes absolutely critical for finding infected people and trying to stop the spread.
Okay, that makes sense. Let's move to the second big controversy the report covers. Cycle threshold values. Seat values.
Yes, seat values. Big topic.
What are they and why all the debate?
So the source explains the CTET value as basically the number of amplification cycles the PCR machine needs to run before it detects enough viral genetic material to cross a certain threshold, triggering a positive signal.
Amplification cycles.
Right.
Like making copies over and over.
Exactly. The machine runs in cycles, doubling the target genetic material each time. It's often looking for a fluorescent signal to reach a certain level.
So a low seat value means?
It means the machine didn't need many cycles to find the virus's RNA. There was a lot of it there to begin with. High viral load.
And a high seat value. Like over 35, the report mentions.
That means the machine had to run many cycles before it finally detected a small amount of RNA.
And what could that mean, according to the source?
Well, the report says it could indicate someone is just starting to get sick, or maybe they're recovering and shedding leftover, possibly non-infectious viral fragments. Or perhaps they were exposed but didn't have a high level of active virus.
Did health agencies recommend using these CTNet values to make decisions?
Actually, the report notes that bodies like the CDC and WHO cautioned against using CTET values alone to manage patients, like deciding if they're infectious or when to end isolation.
Why not?
Because the exact CT number that counts as positive can vary a bit depending on the specific test kit being used, the lab equipment, the procedure. It's not perfectly standardized across the board.
But the report said some places did use them anyway.
It does note that, sometimes allowing people with high CTET values, meaning less virus detected, to end isolation sooner. But the report mentions this was criticized for, well, not being consistent everywhere.
And this is where it spilled into public debate.
Oh, yeah. According to the source, some groups seized on high CT values as proof.
Proof of what?
Proof that PCR tests were generating huge numbers of false positives, in their view, and that these were being used to artificially inflate case numbers and justify restriction.
How does the report address that specific argument?
It explains that this view often conflated two different concepts. One is analytical sensitivity, the test's amazing ability to detect even tiny traces of RNA.
Okay. The other is diagnostic specificity, whether the RNA it detected is definitely from SARS-CoV-2 and not something else. So a high CT positive isn't necessarily a false positive in the sense of finding the wrong virus.
Exactly. The source says that while a high CT positive might mean someone's less infectious at that moment, the result itself isn't inherently invalid. It could still reflect a recent infection or the tail end of one. The report characterizes this line of argument as an example of technical details being, well, sort of used to challenge trust in the overall public health data.
Interesting distinction. Okay. Controversy number 3, according to the report. Assay design and this claim about no virus isolate.
Right. This one is about how the very first CDC tests were developed.
What was the claim?
The claim, as discussed in the report, was that these initial tests were designed using synthetic genetic material, basically, lab-made copies of the virus's genetic sequence, and not actual physical samples of the isolated SARS-CoV-2 virus itself.
And the report mentions an FDA statement.
Yes, it quotes an FDA statement from that time saying, no quantified virus isolates of the 2019 nCoV were available for CDC use at the time the test was developed.
Okay, let's unpack that based on the source. Synthetic genetic material versus virus isolate.
Synthetic genetic material means scientists use the published genetic sequence of the new virus to create matching strands of RNA or DNA in the lab to design and test the assay. A virus isolate would be the actual live virus, grown and purified in a lab culture.
And the report says this is normal.
It explains that this is actually standard practice when a brand new pathogen emerges quickly. You get the genetic sequence first, often before you have time to grow and distribute live virus samples widely. Using the sequence is sufficient to start designing a targeted test.
But critics, according to the source, framed this differently.
Yes. The report notes they argued this was proof the tests couldn't be trusted, that they must be detecting something else, maybe genetic material from the flu or common cold viruses, since they weren't initially calibrated against the real virus.
What was the response from scientists mentioned in the report?
Virologists and fact-checkers, the source says, rejected these claims. They stated the CDC test was specifically designed to target genetic sequences unique to SARS-CoV-2, sequences not found in other common viruses.
And it was validated.
Yes. Crucially, it was validated using clinical samples, real samples taken from patients confirmed to have COVID-19.
Yet the report says these claims persisted for some.
They did. The source points out that these assertions often ignored a key detail. The tests were designed to look for multiple unique SARS-CoV-2 gene targets like N1, N2, RDRP genes.
Why multiple targets?
To increase specificity. It makes it much less likely the test would accidentally react with something else. And the source also mentions that the CDC later removed that initially flawed N3 probe, which further improved accuracy.
But incomplete communication allowed the challenges to stick around.
That seems to be the implication in the report, yes. The technical nuances weren't always clearly conveyed, leaving room for these arguments to continue.
Okay. The fourth controversy area the report covers involves Kary Mullis himself, the inventor of PCR. He passed away in 2019, but became part of the debate.
That's right. The report discusses how quotes, often misattributed or taken out of context, were circulated widely after his death.
Like what?
One example mentioned is the phrase, PCR can detect anything in anybody, suggesting Mullis thought PCR was too sensitive to be diagnostically useful for viruses.
But what were his actual criticisms, according to the source?
The report clarifies his specific, documented concerns were primarily focused on using PCR for HIV diagnosis back in the earlier days of that epidemic.
What was his point about HIV?
He argued, the source explains, that merely detecting HIV's genetic material, DNA in that case, via PCR, didn't automatically equate to someone having an active disease-causing infection at that specific moment. It was about the interpretation in the context of HIV/AIDS, where the relationship between detecting the virus and clinical disease was complex.
So context specific to HIV.
The report emphasizes that, yes.
But how did this get applied to COVID-19 then, according to the source?
Well, the report describes how these specific context-dependent critiques regarding HIV were then sort of generalized and misapplied to SARS-CoV-2 testing.
To suggest what?
To bolster claims of widespread diagnostic errors or even, intentional fraud with the COVID PCR tests.
What does the report say about the impact of misusing his views like that?
It notes that doing so kind of exploited the scientific complexity involved, created doubt, and wrongly positioned the inventor against the tool he created.
And distracted from real issues.
Exactly. It distracted from important, legitimate discussions which the report acknowledges are valid about how best to balance the test's incredible sensitivity with what a positive result actually means for someone's infectiousness right now.
Okay, let's pull back a bit. The report also looks at the bigger picture. Public perception versus scientific consensus. How did agencies talk about PCR?
Well, the source notes that public health agencies often promoted PCR as the gold standard. And technically, under ideal lab conditions, it is incredibly sensitive and specific.
But that message maybe got muddled.
The report highlights that, there was often confusion. People frequently mixed up the test's ability to simply find viral RNA, its analytical accuracy,
with what detecting that RNA actually meant for whether someone could spread the virus at that moment, its clinical relevance.
Precisely.
And the report brings up the view that detecting non-viable bits of virus-inflated case counts.
It presents that perspective, yes.
Yep.
That finding these remnants, especially from high-seat tests, artificially boosted numbers used to justify restrictions or mandates.
What's the counterpoint presented in the report?
The report also includes the view that while these concerns about interpreting results, especially at high C8 values or when prevalence is low, are definitely worth considering,
The test is still useful.
it's still incredibly valuable for finding people who are shedding enough virus to be transmissible, particularly when the virus is widespread in the community.
And the report mentions how PCR testing got caught up in wider debates.
Yeah, it discusses how it became entangled in broader societal disagreements about the whole pandemic response.
Some claims even suggested false positives were deliberate.
The report mentions claims suggesting they were intentionally generated to justify policies like lockdowns or vaccine mandates.
But the source attributes this more to
More to a general distrust of institutions, perhaps, rather than a specific scientific analysis. It notes these claims tended to oversimplify the really complex realities of mass testing during an epidemic.
So the report sees this whole situation as an example of
As an example of just how difficult it is to communicate scientific nuance and uncertainty effectively, especially during a fast-moving public health crisis.
So wrapping things up, what's the core message the report leaves us with?
I think the main takeaway from the report is that these controversies around PCR really underscore the immense challenges that come up when you deploy a powerful scientific tool on such a massive, unprecedented scale during a public health emergency.
And the report seems to suggest that while the debates themselves about false positives, T8 values, assay design, Mullis's views are valid topics for ongoing review and public discussion.
Right.
They don't necessarily invalidate the crucial role PCR played in managing the pandemic based on the evidence presented in the source.
Exactly. The report doesn't conclude the tests were useless, despite acknowledging the genuine complexities and debates.
Does the source offer any thoughts on moving forward? Lessons learned.
It does suggest a few things. One is the need for public health communication to be much more upfront and transparent about the inherent limitations of any diagnostic test.
No test is perfect.
No test is perfect. It also highlights the value of using a mix of tools, investing in rapid antigen tests, maybe wastewater surveillance so you're not relying solely on PCR.
Diversify the toolkit.
Kind of, yeah.
Right.
And importantly, the report suggests that addressing public concerns and claims isn't just about correcting factual errors, it's also about acknowledging that the science is complex, it evolves, and sometimes it's imperfect, especially when things are happening so fast.
Well, we've definitely covered a lot of ground today. We've gone from PCR's invention right through its central and often really contentious role in the pandemic. We've explored those technical debates around accuracy, interpretation, seat values, and also the broader discussions about public trust and communication, all viewed through the lens of this source material.
And that report we've been discussing, it really does put a finger on the fundamental difficulty, doesn't it? Communicating scientific complexity and uncertainty when a crisis demands clear, decisive action.
Yeah.
Which leaves us, and you, the listener, with a pretty big question to think about. How can we, as a society, get better at understanding and discussing the nuances, the limitations of these powerful scientific tools when they're suddenly thrust onto the world stage to tackle urgent public health challenges?
That's a really important thought. Perhaps digging into this specific case of PCR testing, as we've done based on the source report, offers some clues for tackling that much broader challenge in the future.